Okay, everybody, I'm going to get started with the lecture. Those of you still working on the quiz, like I said, you had 30 minutes to do it, so maybe about another 9 minutes or so. But we'll get rolling here. As usual, I'll try to get the recording up on this. Sometimes they go south a little bit. First off, apologies. I was going to release assignment 5. I was going to put the results out, but so far 12 people decided to use AI. So that's been chewing up all my time, trying to figure out what to do about that. So I apologize to the rest of the class who actually did the work. I'll get the results out to you as soon as I can. All right, recap. Where were we? So we started talking about functions. And so one of the questions we asked ourselves is, why do we have functions? And we looked at one of the examples of we could implement the length function using loops going over sequences. But that was really toilsome. And so instead, we just have that simple len function. And we looked at how we could write our own functions. And so fundamentally, what were the functions? A function is, I said, think of it as a machine that takes some inputs. It manipulates that data or those inputs, and it produces some outputs. So if we had a function to make tacos, it could take as input ingredients, it could do some stuff to it and produce a taco. The actual makeup of a function, what does it look like? It looks like what we saw for ifs, for branching, or for loops. It's a combination of keywords, some name that we provide for that function, parameters, that colon and indentation to say, hey, this is the code I want you to execute. And then magic, all the code that we're going to write custom for this program. Really important to functions is the concept of arguments and parameters. And I had mentioned we really want to remember that the argument, actual, that's the actual value that we pass into our function. So if we have a function greet, when I pass Dan into greet, that's my argument. The parameter P is a placeholder. I'm saying greet with this name. It's highly unlikely I want to print hello name. I probably want to print something like hello Dan. All right, so the new material for today, it's a pretty easy section, and I have seen people starting to sort of do this in parts of the code, which is great. And it's called function stubs. Generally, when we program, we don't always know what we're being asked to do. Somebody will say, hey, I want you to build me an application to plan a trip. But what's involved with that? We might not know. We might not know until we can put an application in front of our product manager or our product owner, and they can say, oh, yeah, that's not exactly what I meant. Can you change it up? I want to highlight something. Anytime we're given a problem, our job as computer scientists is to solve problems. And so the best way to do that is to sit down and just start blasting out code. So if somebody said to me, I want you to build an app to plan a trip, this is how I would start it. Print, planning a trip. And it's really not much more complex than that. It's just something. It just gets something down on the computer. What would be my next step? Well, my next step, we've learned all of this stuff. Maybe I would ask the user, where would you like to go to? How much would you like to spend? And how many days are you going for? And in this simple program, I would print out vacation plans, 10 days going to Lisbon, costing $1,200. So presumably I want to spend $100 a day. So that's a perfectly reasonable program. But again, likely our programs are going to be a lot more complex than this. So this is where our functions come into play. So we looked at the function definition. Here's a function for a trip planner. And you'll notice here how I sort of stubbed this out. My locations is none. I'm not going to spend any money. My duration is 0. And I have my print statement. If I want to invoke that, I just say trip planner, much like how I would say input, something like that. All right, so this isn't a very useful function, but it's something. It's a starting point. So you can see here my vacation plan, 0 days going to none, costing 0. So what would be my next step here? Well, my next step here would be to think about the parts that are involved with planning a trip. And so we have to figure out where to go, how to do the budget, and the timing. And so this very simple program that we looked at might get split up like this. Now, if this is all that was to it, this is probably the overkill. But again, it's a good place to start if you're building a legitimate app. So if each one of these steps was way more complex, this is where the stubbing comes into play. I really like the way Zybooks gives the options for this. I think, after coding for years and years and years, I just naturally do this stuff, but they did a really good job of outlining what some of your options are. And so one of the options that they talked about was when you define your function, just simply printing out a message that says, fix me. A lot of times, in other languages, it's not language specific. You can put whatever message you want in there. You could say to do, right? But here it's very clear, fix me. You're sort of implying something's broken here. I'm not done here. But I do have to give some context of what I need to finish. And so that's this function. And again, you can put in whatever you want, but here that just kind of makes sense. The other thing that Zybooks mentioned with this was returning -1 on a function. Not the best thing in the world all the time, but if you do it consistently, at least you can keep up with your code. There might be some cases where you want to return -1 legitimately, but it's not the worst practice I've seen. So that little more complex function, what I would do is I would end up doing that in all of those atomic functions that I was going to build. And then once I had everything stubbed out, that's what we call that, stubbing it out, then I would go back to that main trip planner function and simply call those functions. From one perspective, my trip planner function is done. I've done my job here, but there might be a lot more I need to do in these specific sections. Likely what you would do is you would give one programmer here, you go build this function, another programmer builds that function, another programmer builds that function. That's really how this kind of shakes out. What are the pros with this approach? It's pretty clear what you need to finish. So I said here, finish where to go, finish budget, finish timing, right? As I build those out, obviously I would get rid of those prints. The program runs. Yeah, it's going to run end to end. I'm going to get output. But do I actually want it to run? Do I want this program to run if I'm spitting out garbage numbers? Debatable. The next option they talk about, and we'll do a whole section on exceptions and errors. Here's a new keyword to appreciate, something called raise. So we can raise not implemented error. And we've seen this in a variety of places before. So when we tried to use a string as an integer, or when we tried to access an index that wasn't in our sequence, something like that, we get errors. So you as a programmer, you can raise your own errors too. So if somebody were to call this function, I would immediately get an error. Again, iterative development, I would put all this in each one of my atomic functions. Then I would go to Trip Planner and build that out. So what are the pros with this? Well, there's no semantic errors. There's no way I can actually put in a bad value for budget or a bad value for timing. It's just going to throw an exception. And so therein sort of lies the cons. I can't run this program, right? It's going to as soon as I get to where to go, it's going to throw an exception, an error, and I'm not even going to be able to test this code here. Also, just doing the raise, it's not really clear. I'm not really sure where the exception was thrown. If I maybe inverted these lines, I did the spend before the location. I'm not exactly sure who's causing the problem if I don't have access to the source code. The third option discussed was this concept of pass. So pass is another keyword. This is something I've not seen in other languages. This is something unique to Python, and I actually really like it. I think it's a pretty good idea. What it means is, it means execute this code, but don't do anything. Don't return anything. Don't throw any errors, right? So it's sort of like the -1, like returning -1. But the problem with it is, it doesn't do anything, right? So when I run my code, yeah, it runs, but what am I going to get back for location? Probably none. What am I going to get back for spend? Probably none. A lot of times you want your functions to return stuff. You're not returning anything here. So none of these are bad ideas, by the way. They're just options for you to consider when you're writing your programs iteratively. So we'll do our usual here. Let's jump over into EdSTEM. I put the link in Blackboard for assignment 7. You won't see the big point stuff just yet, just the small point stuff. But if you want to follow along, code along, they're here. Later on, if you want to just see the solutions are up here as well. Okay, so the first thing we're going to do is, let's pretend we don't even have functions. Where might I use something like pass, right? And what I'm going to do here is that assignment we had where we were checking for syntax and semantic errors, where I was checking somebody's age. So here, I might want to do something like this. If age is less than 18, I don't know what I want to do. I don't know if I want to print a message. I don't know if I want to return a value. Elif age is less than 21. Same thing. I don't know exactly what I want to do here. Else, also pass on this one. So we can run up that code. All right, just gotta get my quotes right here to comment on his code. Okay, so when I run this code, I can put in any age, really. You are 90, you can none, right? This value is never being set. Where else might I want to use this? I might want to use it when I'm stubbing out loops, right? So when I stub out a loop, what do the instructions say here? Write a loop that repeatedly asks a user for an age. Okay. Just say while does not equal age. Let's ask the user for their age. And this time, I might do this. I might put the fix me in. And again, notice the IDE is going to sort of give me a hint. It's going to kind of do it for me here, right? Fix me, fix loop. Something like that. So let's run that up. Age, this is our first. This is our second part. 90. Fix me loop. 23. Fix me loop. 12. Fix me loop. 65. Fix me loop, right? So it's a signal to me as the programmer that I want to go in and clean that up. Okay. There's another part in here which I'm going to skip, which is just combining, putting that if statement inside the while loop. You can kind of do that on your own. Okay, different ways to stub. Let's do this trip planner one. Write a function, trip planner, with no magic, so no real code. Call it try out pass. Okay. So I would do something like def trip planner. Simply say pass. Then if I want to call trip planner, go ahead and run that. Not a very interesting program, doesn't really do anything. Maybe if I want to be a little bit more clear, I can do pass and fix me. So I'll do print fix me. Implement trip planner. Just put a message here. Fix me, implement trip planner, fix me, done. If I want to, I can say return -1. And now I can actually catch my value here. Return val equals trip planner. We can print that out. I'm getting that -1. If I didn't do that -1, it's just going to give me none. So done and none. Okay, so this is going to come in really handy. We're moving into the sort of second part of the course where we're going to be doing the project. And the project is going to be a little bit chunkier, where we say, hey, I need you to write very big functions. I need you to write modules, right? Like a whole collection of stuff that we're going to put into separate files. And a lot of times you're not going to know what you need to do. And so you just kind of write the function and say pass or fix me or something like that. And then we'll move back to it. Okay, the next topic we're going to get through here is the idea of dynamic typing. And hopefully we all remember when we use the length function, we can pass a lot of things into length. We can pass a string. I have a list of bytes here. I have a list. I have a tuple. I have a range. Then there's these collections. We can pass in a dictionary, a set, some data structures that we haven't gotten to yet. So that one length function is doing an awful lot of work for us, right? The way it's actually working, if you did kind of look under the covers, I mentioned this briefly, it's actually written, I think it's written in C, it might be C++. But if we examine the code conceptually, what's happening here, def len, so I have some function, and it doesn't take a string, it takes an object. And what the implementation of this object does, it says object dot, and it calls this funny looking method name. And now if we remember our rules for creating methods, for creating variables, there's nothing wrong with this variable name. Underscore, underscore, len, underscore, underscore, open paren, close paren. You're going to see that a lot. That's a common syntax inside Python. And so what this is basically doing is saying, hey, if you pass me in an object, and that object has this method, I'm going to call it. And what's going on inside here is that for loop we saw before, where it's basically iterating over the elements in the collection. So there's not a lot of magic there, but that's fundamentally what's happening with len. And then, again, this exception, this error stuff we talked about, we'll go into more details. But basically here, right, if you try to pass something into len that doesn't have a length, right, like a float or something, you'll get this error message. You know, object of type float has no len function. All right. Very big word. People who have been in Java land or even JavaScript land or C++ land, there's this concept called polymorphism. I think it's Greek, and it means many forms. And just like with length, where I could pass in any sort of objects, polymorphism is this concept where we say, without knowing what something is, I can perform an operation on it. And so if we think about shapes, right? I can calculate the area of a shape, but calculating the area of a circle, that formula is vastly different than the area of a square, right? I'm not going to go into the details on that, but I can write a function called calculate area, and that will take a shape. It doesn't really matter what sort of shape it is, as long as the shape knows how to calculate its area. Covered later, again, folks who have been into Java land, there's the concept of method overriding. And you'll see in a lot of languages, there'll actually be multiple implementations for the len function. They'll have a length function for string, a length function for lists, a length function for dictionaries. And with something like Python that's dynamically typed, there's only one. There's only one method called len. There's a concept called interfaces, which, again, we won't get to until the end of the semester. Do have an appreciation, though, with this terminology. Please remember polymorphism. That's likely to be a question I ask, because you definitely need to know that when we get on to classes. But also have an appreciation for different types of languages, static versus dynamic typing. So dynamic is things like Python. I don't really know what the type my object is. I just pass anything into len, and if it works, it works. Other languages are statically typed. Things like Java, C++, right? A lot of your languages for mobile devices, Swift, Kotlin, C#, right? Those will be statically typed. Some other ones, actually, Objective-C used to be a programming language for iOS phones, but not so much anymore. Okay, so over to the dynamic typing one. There's really not much to this, but we can take a peek anyways. So I copied over here our existing myLen function, right? So myLen, what did I do? I had a counter variable, I had a for loop, I incremented count, and I returned it, right? And that said my string or whatever had this length. So string, length of the character, string AAA, right? That has length 4, right? If I go down here, though, let's change this up a little bit. Let's ask for 3 things here. Let's ask for 3 things. Let's ask for A, B, and C. And I'm going to put those things into a list. A, B, C. And we'll just start out, we'll print that out. Actually, just comment out this code up here. Okay. AA, EB, CC. That's my list. Now, I have this same function up here. I'm not going to touch it. I'm not going to change a darn thing in this thing. But now I'm going to say my length, and I'm going to pass in my list. Let's do that same thing. AA, EB, CC. So my list has 3 things in it, and this correctly said, okay, you have 3 things. Let's try, I can put strings of any length in here. It doesn't matter because it's only counting the elements in that list, right? That's still giving me the right answer. So this is sort of the beauty of a dynamically typed language. I did not have to change my code at all. What I likely would do as a programmer, though, is I'd come in here and I'd probably update my documentation. I would say, determine the length of the given. In this case, I would say sequence, because I know both of those things are sequences, right? Variable S still seems to work, so I could use that, right? Or maybe as I develop my program, like, oh, it works with other types. So iterables, right? And so then maybe, I don't know, maybe at that point I change this to I, something like that, or C and I don't know. So that's really all there is to dynamic typing and static typing. With respect to where we are with chapter 7, if you're following along with these slides, I'm commenting out in gray which ones we covered. And so we just knocked out these two here. All right, what's coming up? So tomorrow night, and sorry for the late notice on this, I'm finishing up the practice exam. I should have that done. The TAs are going to take the practice exam and the real exam this evening. But tomorrow night from 5 to 8 over in Martin 454, happy to do an extended study session. Wednesday, don't forget, assignment 6 is due. Similarly, 5 to 8 that night, I'll do an extended study jam, office hours, anybody who'd like to attend. Wednesday, we will do functions. Friday, we're going to pause on functions. We're going to do exam prep. If you haven't had a chance to go through the practice exam by then, we'll do it in class. I can answer your question. And then Monday is the exam. Anybody who needs extra time for the exam, if you have that far walk here, you can't get out of your other class, please let me know. I'm happy for you to take it a little bit earlier on Monday or a little bit later on Monday. But that's really the window here. So anybody who needs extra time, extra accommodations, just let me know. You don't have to be here for it. If you can get here earlier, take that exam. We can't be hanging out in this room like we did last time until 3 o'clock. I got some nasty grants on that. So 2:50, we're pretty much done with the exam on Monday. All right, everybody, take care.
I was doing important. I think we're short, so